Hello and welcome to this Nordic Tech webinar using Cellular IoT in predictive maintenance. So in this webinar you're going to learn how to reduce costs and downtime by predicting failures and scheduling maintenance before a breakdown occurs. We will also investigate the different low power wide area network technologies currently available and the landscape of cellular IoT today, coverage, and also the future of this technology, especially for 5G. There's also an essential part where I'm going to talk about the difference between low power cellular IoT and Cat 1 bis, which technologies should be used for what type of use cases. And at the end, I'm going to talk about why cellular IoT suits predicting maintenance applications, and also why machine learning can be beneficial to integrate into your applications. And today's host is me, Martin Lesund. I'm a technical marketing manager for Cellular IoT. Been working for Nordic around 5 years. Started off in a tech support group for 3 years and always been very interested in cellular IoT and the potential of this technology. A little bit about practicalities. The duration of this webinar will be around 30 to 40 minutes, and also we'll have a Q&A session at the end, so questions are therefore very encouraged. So please type the questions at the top of the right sidebar. All questions are anonymous, but try to keep them relevant to today's topic. The chat is not anonymous, so please don't use that for questions. If you have any more questions after this webinar, you can go to our technical support forum, DevSol, and you can either create a private or a public ticket. A recording of this webinar will be available after this live webinar, together with the slide deck. So the agenda for today: current landscape of LPWANs, evolution of cellular IoT and 5G, how cellular IoT enables predictive maintenance deployments, and how to benefit from using machine learning. First off, we have the LPWAN landscape. So LPWAN, that stands for Low Power Wide Area Network. And these are typically wireless networks designed for long-range communication at a low bit rate. This means that it targets low power and low cost devices. There are many flavors, and they have different topologies usually and different use cases. The most popular ones are LTE-M and NB-IoT for cellular side, and also for the unlicensed side we have LoRaWAN, which is most popular there. And you have probably heard LoRa and LoRaWAN, so what's the difference? LoRa refers to the physical layer, which is owned by the Semtech Corporation, while the LoRaWAN refers to the MAC layer specification, which is maintained by the LoRa Alliance. And if we look more into these technologies on how they kind of are in this landscape here, so comparing the y-axis and the x-axis, we see the power consumption and the maximum throughput. And we can see the different cellular technologies and also some unlicensed technologies. For us, Nordic, we support LTE-M and NB-IoT, as well as DECT NR Plus in the future, which is the NR Plus logo you can see on the right-hand side. And we're not going to talk about that in this webinar, so if you're interested in that, you can look into the introduction in the DECT NR Plus webinar. So for LTE-M and NB-IoT, you can see they are in the middle ground with regards to max throughput here, and but they also are a very low power technology. And of course, low power is in the Nordic's DNA, so that's why we are integrating and developing products using these technologies. And other great benefits with these technologies is that it's an open standard developed by 3GPP. You already have the existing infrastructure all around the world. It's future-proof, meaning 5G ready. And also you have decent amount of throughput for IoT use cases. You also have scalability and security and reliability and quality of service inbuilt in the technology itself. And here you can see the map of where you have LTE-M and NB-IoT connectivity around the world. So it started off actually in Europe where they only focused on NB-IoT, but more and more countries now support both because they see the big benefit of supporting both. So many modules support both technologies. Our nRF9160, for example, has support for both NB-IoT and LTE-M. So there are some differences here. We're going to look at that later. But just notice that the largest parts of the world are covered already with LTE-M and NB-IoT. And we expect to see more countries that roll out after some time. Here are the LTE IoT technologies. So typical IoT devices would use this type of technologies on the cellular side, and on the right hand side we have the low power wide area network technologies. These technologies were designed for low power devices which would connect in millions. And LTE Cat 1bis has become more and more popular as well as an IoT technology. It's a very good technology for many use cases, but it should not be kind of confused with LTE-M and NB-IoT and some use cases. I'm going to talk about that later on as well. But LTE Cat 1, that came out in 3GPP release 8 in 2008, I think. And LTE Cat 1bis basically means that you remove one antenna. So LTE Cat 1bis means that you can have one antenna running full duplex. And you can see the bandwidth is much higher on Cat 1bis compared to LTE-M and NB-IoT. Also, you have a lot more throughput. And with regards to range, you can see typical 4G range on Cat 1bis, but LTE-M and NB-IoT has a lot better range from the base stations. You have included mobility support in both LTE-M and Cat 1bis, and roaming is supported in LTE-M and Cat 1bis, but not it's limited on NB-IoT. However, NB-IoT is the only network technology here that has great deep indoor coverage. And with regards to where these technologies are deployed, so Cat 1bis, you can use that wherever you have 4G already, so that's more or less global. And as you saw, LTE-M and NB-IoT is mostly covered. With regards to deployment density, there are some differences here. You can have up to 50,000 per cell on LTE-M and NB-IoT, and around 5,000 for Cat 1bis. With regards to battery life, this is of course very kind of speculative. It's depending on your predictive maintenance applications, how often you send data, etc. So this is kind of just to give you an impression of on the difference here. If you use the same application on both devices, you would see a kind of a 1 year to 5 year difference. But can you use Cat 1bis for massive IoT deployments? So here are some things that you need to know. It has global coverage on the network side. Where you have 4G, you can access with Cat 1bis. However, it's not that easy from the module side. So there's not too many modules as I've seen that has global support. You either have APAC specific or US specific or some combination of the different regions, but I yet to see any global modules yet. And one of the reasons for this is it's a bit more complex to develop. You have full duplex operation, which causes complexities with regards to to the design of your devices. You need, for example, more complicated RF front-end and tight filtering is necessary, whereas LTE-M and NB-IoT has much less complexity. But this is relative, right? So comparing Cat 1 base to much higher categories, it's more easier again. One great benefit with Cat 1 base is that you have high bandwidth, so you can send a lot of data in short amount of time. And but again, power requirements, that depends on the use case. So it's not designed for small battery operated devices. It's more use cases where you have a touch screen and you need to send and receive voice, for example, through this touch screen, or stream data for cameras or other similar applications. And also, the power requirements are higher with regards to peak currents, so you cannot use the same type of batteries. So it's very important to select correct battery types and technologies if you are going to use batteries and not mains powered in a Cat 1 base application. And you can also expect more costs, both on the module side and also on the design cost with regards to designing also the product. And finally, this is kind of the message between LTE-M and NB-IoT versus Cat 1 base, is that LTE-M and NB-IoT is designed for massive IoT. That's developed for targeting those kind of applications, while Cat 1 base is broadband IoT and tries to capture those types of applications. And now over to the cellular IoT evolution from 2G to 5G. So as you can see on the left hand side, we have the 2G and we go into 3G and the 4G, where we got Cat 1 and also LTE-M and NB-IoT, which are IoT focused. And on the right hand side, you can see the 5G triangle, where you have these three different aspects where the technology is trying to address. You have the enhanced mobile broadband, you have this ultra reliable low latency communication, and also this massive machine type communications. And massive machine type communications are typically IoT low power devices. That could be smart city asset tracking, could be predictive maintenance, could be etc. etc. On the ultra reliable low latency communication area, you have things that needs low latency. And this could also be life critical devices. It could be factories that needs to send data as soon as possible. Could be automated cars using this, etc. And enhanced mobile broadband is more towards typical cell phone use, VR, AR streaming, and so on. And here you can see the different LTE categories and the evolution of that. We have the Cat 1 at the left hand side, which goes down to Cat M1 and Cat NB1, which is LTE-M and NB-IoT. And basically, going down this, you can see we have lower data, lower speed, but also lower power, lower cost, and enhanced coverage. So there's something that you lose, but you're also gaining something. And going up the ladder, you can see the typical mobile categories where you need higher speed and higher bandwidths. So what happens with 2G, 3G and 4G going forward? So right now we can see that there's ongoing shutdown of the older generations. 2G and 3G has its sunset because of the spectrum is needed. So there are many countries that has shut down their 3G and 2G networks. And there's many countries that has a target by 2025 to shut down these technologies. So it's important to be informed of this. If you have any devices outside using these technologies, they need to switch over to newer technologies. And with regards to 4G, there's no need to refarm 4G frequency bands to deploy 5G. And there's coexistence possible of 4G and 5G. Both use the same modulation in a compatible time and frequency grid. So it's a very important part here is that coexistence is a major 5G feature and extends the 4G lifespan. So you can expect that your 4G devices will have a longer lifetime, especially LTE-M and NB-IoT is brought into 5G because it meets the requirements that are set in the MMTC. So if you have LTE-M and NB-IoT devices that uses 4G, it will still work on the 5G networks, and that is also guaranteed for a long time. So it's future-proof. And now over to predictive maintenance. There are different types of maintenance. You have reactive maintenance, which is typically when you see the device has actually broken down and you have some downtime, and this can be expensive and it's unplanned. So let's say you have a motor that has suddenly broken down, then you need to do some maintenance. That is called reactive maintenance. Then you have something called preventive maintenance, and that is basically using history of past failures of the equipment, and then you kind of schedule in maintenance to take care of this equipment. So this will limit the potential downtime, and it could also be cost saving versus reactive. So this is different from use case to use case. You can have a robot in a factory line, which if that breaks down, you can lose a lot of money if it's stuck several hours. So it could be good to have a preventive maintenance there, for example. And you also have something called condition-based maintenance. And this relies on sensor data. And this is taking measurements of a device. Let's say your car engine. You can see your car engine light suddenly pop up, and that means you need to go and check your engine, right? And this is reliant on sensor data, and maintenance is only scheduled when the performance has decreased outside the specification. And this can be very highly cost effective and very cheap to implement in our device. But if you want to go one step further, you can implement something called predictive maintenance. And this is data-driven, and maintenance only occurs when needed. It basically utilizes condition monitoring and can use this data to predict when you will have a failure. So, predictive maintenance overview. This is basically a maintenance strategy to predict when equipment will likely fail, and this allows for a proactive action to be made before the failure occurs. And there's a institute here, McKinsey Global Institute, has reported that implementing predictive maintenance practices across manufacturing will have huge effect, 240 to 627 billion in cost savings across the industry. And the benefits of using predictive maintenance is that you reduce downtime and minimize maintenance cost, and also improve the equipment performance and longevity. And kind of the same thing goes for you yourself and going to the doctor, right? You can wait until you get sick, and then you take some actions on this. That's called reactive maintenance, right? But if you had like a smartwatch that suddenly tells you, okay, there's something ongoing here, please go to your doctor and do some maintenance work, basically. And that's what predictive maintenance is trying to do on the equipment side right now. But where does it make sense to use it? Every machine and system is subjected to wear and tear. So you could either just wait out and see when you need maintenance. wait until it breaks down and then take action. Or you can do this standard switch out the filter each year, or you can take the decision to use predictive maintenance and actually track what is going on the device itself. So it can boil down to a cost decision. So you can see on the right hand side, you can see costs on the y-axis and number of failures on the x-axis. And we can see the blue line is total cost, and the green line is preventive cost, and red line is repair cost. And you can see the increasement of repair cost is highest when you actually have a breakdown of the device. And this is dependent, of course, of the equipment and the downtime, etc. But it can be expected to have a very high repair cost. While if you do preventive maintenance, that can reduce this cost. But you need to kind of have a middle ground here where it's optimal to have predictive maintenance, basically. So it goes down how dependent are you on the device running. Factory line applications are depending on that everything is working. So if one thing breaks down, you're kind of stuck because you then have a bottleneck. So then it's much better to monitor every device there. And since sensors and devices now are becoming cheaper and cheaper and easier to deploy, also thanks to cellular IoT, it makes more and more sense to go this route to use predictive maintenance and implement that. And we see this around the market now that it's been very popular and with great success of cost savings, basically. But why would you use cellular IoT and predictive maintenance? You could use wired technologies, you could use short-range technologies, whatever. But with cellular IoT, you have this reliable connectivity, which can be very important for receiving the data from the devices. And with cellular IoT, you have this inbuilt secure communication and also the reliability. And also a big part is the wide coverage. You don't need to set out your own base station or any gateways. You just deploy, and you usually have a base station in the vicinity of your application area. So it's has more coverage compared to other options usually. And also you have this scalability. You can have thousands to millions of the devices in the same area. And with cellular IoT, you can also have real-time monitoring, which is required where you need alerts in real time when maintenance is needed. And this, of course, can reduce the maintenance cost. Deploy the device that can run for years, basically, and only do maintenance when needed. Now a little bit about machine learning. So here you have kind of the option of processing either on the cloud side or the device side. So using it, processing the data on the cloud side, there you have a lot of processing power available. But then you would burn power consumption on the device by using the radio to send all this information all the time. You can also expect higher latency with regards to sending data and receiving data. But and also higher cost can be expected with regards to data processing and network traffic. Let's say you have more and more devices sending data to your cloud. That will increase the costs, but also if you're sending through cellular, that can also increase the network traffic, which you usually pay for, and also power consumption could increase there. And if you have poor wireless connection, that will affect the data sending to the cloud. So in some cases it could make sense to send everything to the cloud and process things there. But in other cases where we have battery operated devices, it doesn't make sense to use the cloud. Instead there's a better way for that. That's processing everything on the device, also known as edge computing. This is power efficient and does not take up the network. You're basically processing the machine learning models on the device itself and only sends events or alerts when actually needed. So you don't stream all the data to the cloud, but process it on the device. This is also good that you process in the same environment that the data is captured. You will have a kind of lower latency until anything is kind of processed. But this can also enhance privacy and data security, right? Because you have everything on the device side, and not everything streaming up to the cloud. And what do you need to think about when using machine learning? Basically use historical data and live data to analyze failure patterns. So you need to kind of consider which sensor to use, what makes sense to use on that type of equipment. Let's say you have a motor, then it could be good to have an accelerometer and also a temperature sensor. And other use cases, it could be good to have a humidity sensor, etc. So that is important to decide. And you also need to kind of look into what type of failure generally occurs on that type of equipment. How does the failure process happen over time? Is it like a slowly wear and tear, or is it a sudden leakage, for example? And which parts or processes are related to the type of failures is important to consider, and look into the data collection over time and how this may change. And also you need to kind of know what type of output should the machine learning model give. Should it use historical data or static data, or and you need to kind of have all the events recorded, labeled and logged while you track things. And on the right hand side you can see this Thing91 prototyping platform that we have, and there's a developer that has set up a predictive maintenance project. So he has created his test bench, which uses I think 2 motors and simulating kind of different breakdowns, and he's using machine learning to capture these breakdowns, right, and send that to the cloud. And if you want to look more into this, that's posted on Edge Impulse blog site, or just click the picture which is in the slide deck when you receive that. So we have a collaboration with Edge Impulse there in our Nordic Partner Program. They make it quite easy to implement and deploy machine learning models. And we have support for them in our open source SDK and different samples. So it makes it quite easy to test the waters with machine learning if you haven't done that before. But it's highly effective, and these models runs on the device itself. So you process the machine learning models and the data on the device itself. So you can capture many sensors at the same time as well. So there's many benefits of using machine learning. You have improved accuracy compared to just reading out a sensor and doing some simple events from that. You can capture large amounts of data and therefore make more accurate predictions than traditional methods. You can also expect early detection, and this can optimize the maintenance schedule based on the machine learning predictions and detect the failures before they occur. And also scalability here as well in machine learning. The more data you train, the more that can improve the performance. And you can scale with more devices or sensors here as well. But now let's look at the power consumption, because low power is in Nordic Semiconductor's DNA. We are always focusing on power consumption, and in Cellular you are using more power when the radio is on, right, when you have to send and receive things. So the best thing for a total power budget is to send rarely. But when you first turn on the radio, it's good to send a good amount of data, because you are using more power consumption in the setup than sending the actual data. So if you see here, you can see you have which we have called it a LTE event, which is basically waking up the device, sending it, and going back to sleep. In the beginning here, you have the network sync, you have SIM synchronization, the RC setup, and then you send 64 bytes of UDP data in this example. And then you go to these CDRX events, and then you get the RC release from the network. And then you can actually go directly into power saving mode, but in this case you are in EDRX for a while to see if there's something to be received from the network, and then you go into power saving mode. So all this is kind of captured in this LTE event, and you can see that only around 3% is actually the data itself that's sent. So for LTE-M and NB-IoT applications, it's good to have follow this rule of thumb of sending data rarely, but you can send a good amount of data when you actually do it. That to reduce the power consumption usage. But now let us look into the LTE usage versus the CPU usage. So this is to kind of show you that it's much more efficient to process the data on the device itself with regards to power consumption compared to sending this data to the cloud and processing it there. So this is some calculations on how much CPU runtime for the cost of this LTE event, as we saw on the last slide. So you have this 64-byte upload data LTE event on the Cellular network that we showed earlier here. That consumes 84 millicoulomb. And our computations here, you can see that you can run the CPU at 64 megahertz for 38 seconds continuously to achieve the same power usage. So that means you can process a lot of data compared to just sending this LTE event. So you can definitely see the big benefit of using the CPU of processing machine learning models rather than sending that to the cloud. So the advantages of the nRF9160 system in package. So all that I've talked about can be used with the 9160. So on the right hand side you can see the block diagram of our system in package. Inside we have the power management IC. We have an application processor which is open for the developer to program their own applications on. You have 1 megabyte of flash and 256 kilobytes of RAM, and also available different peripheral I2C, UART, etc. to connect to your sensors. And of course you have our modem, which also has support for GPS. And you also have included the RF front end. So basically you need kind of a power source to drive this. That could be a battery or mains powered, some sensors, and then a SIM card and a couple of antennas. And then you're good to go. So you have a complete package here, which is 10 by 16 by 1 millimeter. That means you can have a smaller PCB and also reduce on size and also bill of materials, because you don't need an external host or anything to run this. You have everything here. And of course, lowest power, we have the lowest power device on the market with regards to LTE-M and NB-IoT, a total package. That's because we have a bottom-up design from scratch, focused on low power. We have optimized the radio performance, and we also include new low power features in our modem firmware releases. All these to increase the battery life and the device lifetime of our customers' devices. And in the middle here, the advantage is the ease of use. We provide a complete open source software development kit, and we have complementary tools. Device is globally certified, and this also means a faster time to market. So that means you can use this device wherever you have LTE-M or NB-IoT network coverage, basically. And now you can also register for upcoming Nordic Tech webinars. So next week we have a low power Wi-Fi webinar, which I highly recommend to check out. But now I've gone through my material and I'm ready for some questions from the audience. How much power does Cat 1 bis use? How much more power does Cat 1 bis use than Cat M1 for a typical network registration and small data transfer? So that depends on which type of module you use, firstly, to compare that apples to apples. I don't have the numbers, some numbers here right now, but a typical rule of thumb is that if you look at 9160, you need to have TX and RX added together because you have full duplex in Cat 1 bis. So you usually can see that adding those together plus 10%, you get some numbers there. But yeah, definitely this is something that that could be interesting to look more into. But the next question, can we take screenshots and publish on social media? So this webinar is public. You can definitely do that if you want to. And the next question here is it true that for both NB-IoT and LTE-M are now covered across the whole of the British mainland? It used to be east and west split. So right now, LTE-M is on the west side, I think, with and also you have some other carrier on the east side. So technically, you have country-wide coverage, but I think definitely there's some processes there that everything will be supported in the future. But I think now it's still some kind of split there. Okay, next question. I see myself in reactive maintenance as I lose connectivity, losing my telemetry data. Doesn't 3GPP recommend how to use multisim when using LTE-M? Or is this open to individual applications controlling the modem? I'm just trying to understand the question correctly here. Yeah, I think I need to look more into that one before I can answer. I'm not sure if I understood the question correctly, but I can take the next one here. Is it possible to set up a private NB-IoT or NB-IoT network? Have heard of this being a thing for 5G. Yeah, I think it's possible that you can do that. I haven't looked too much into that myself, so I would need to investigate that a little bit more, unfortunately. The next question is machine learning in predictive maintenance better than having memfault, or do you see them complementing each other? Oh, that's a very good question. So definitely I see that more as complementing each other. We have customers using both. So memfault is basically an observational and also device health platform of your devices, and also which type of application is running on devices and fleet management. While using machine learning, you are actually making models to interpret the different data and give out some useful data out of that. So they kind of complement different things, and they will definitely complement each other in those use cases. Next question. Based on your experience, can you recommend some multi-SIM companies that can enable good connectivity globally? So yeah, okay. We have some connectivity partners, and that is on our website that we feel cover a lot of ground and implement PSM and EDRX. But I'm not sure if there's a company yet that has global support with a SIM card. But there are many countries that support many countries. So Many MVNOs has this listed on their website, so I just would recommend you to look into different MVNOs and look which country do they support. And also a big thing is, do they support several carriers in the country? So if you are in a place in a country where you don't have coverage with your one carrier, you should kind of automatically switch to another one without thinking about it. So it's important to note that you should have more than one carrier in each country covered. And also a major thing with at least LTE-M and NB-IoT is that you have power saving mode and eDRX features enabled or available, at least using this kind of SIM cards, because many networks don't give roaming SIM cards this features here. So there's kind of an agreement from the MVNO and the MNO that these are working. So this should also be investigated. I think that was yeah, okay. I see some questions in the chat as well. So there was a mention here about 5G RedCap. So I didn't touch upon that in my presentation, but it's a good point. That is something that is coming in the future. 5G RedCap is kind of not directed to massive IoT. It's more like taking over for Cat 1bis. So it's more directed to in the triangle of the 5G. It's kind of the middle ground. So it has higher throughput and those kinds of features compared to LTE-M and NB-IoT. So it's more like a broad band IoT, I would say. And there's also a question in the chat here. I heard that AT&T and Verizon, for instance, still do not approve LTE Cat 1bis on their networks due to loss of performance. Any field feedback on this? So I've heard similar things. That's the only thing I can say. So I think they definitely want to have LTE-M and NB-IoT devices instead, with regards to not using too much bandwidth on their spectrum. So that is also some thing you need to consider if you're choosing between Cat 1bis or LTE-M or NB-IoT in your devices. So yeah, cellular is, there's many things that you need to think about. Will Nordic support non-terrestrial networks release 17.3 GPP? So it's a good question. Unfortunately, I cannot answer any roadmap questions on this webinar today. So I will highly suggest you to go to our regional sales manager and check there. If you don't know who that is for your area, you can go to our website or just go to DevZone, our technical support forum, and ask there as well. And there's another question here. Will the slides be available after the presentation? Yes, they will. So on webinars.nordicsemi.com, there will be a recording of this webinar as well as the slide deck that was used today. So any links that's posted in the presentation will be available for you to look at later on as well. And there's a question here. Wouldn't running AI models consume more than just sending 64 bytes? Or would you be able to provide some power numbers with commonly used AI models used in predictive maintenance? Thank you. So the example I gave was just from general, speaking of using the CPU on the device at 64 megahertz for 38 seconds continuously, compared to sending 64 bytes. So it means that processing the data for 38 seconds is more efficient than sending this data, this small amount of data. So it's much better to process machine learning models on the device compared to sending, streaming all this data to the cloud. So if you have an accelerometer meter, you shouldn't stream this great amount of data to the cloud and process it there. It should be processed on the device because it's much more power efficient. At least when using companies' machine learning models such as the Edge Impulse is very efficient. So I highly recommend to check that out and do your own power measurements. I don't have any specific numbers with regards to that. So either you can ask on DevZone or try it yourself. We have samples in the SDK that uses machine learning models. And you can also buy a PPK2 if you don't already have one. That's a very cheap and efficient way to measure power consumption on any device, on the low power devices. And here's another question about power consumption with regards to sending tracking area updates. So let's assume I want to send an update to the cloud every 15 minutes. Is it more power efficient to request a periodic tracking area update every 15 minutes or request a maximum time periodic tracking area update? So in my experience, it's just best to just request a maximum time, and that should be the most power efficient one. I think you actually update this tracking area update each time you go to RC connected mode, if I'm not mistaken. But I think definitely every time you connect, you use power consumption. So having a periodic tau every 15 minutes and not sending data would not be power efficient, because then you would be stuck in this RC inactivity timer, right? After you are in connected mode, you have to wait a bit to go back to idle mode. So each time updating the tracking area update would just burn off battery without being efficient. So yeah, I would definitely request a maximum time periodic tau. So that's basically all questions for today. And thank you very much for following this long. I hope it was interesting. And please register for next week's webinar, which is about low power wireless and Wi-Fi, actually. Low power Wi-Fi. So please check that out and have a great day.